Welcome to our channel Circuits Analytica. In this video, we will discuss a tutorial on mesh analysis. For the following network, find IY and power supplied by 10 volts source. Mark the loops as 1, 2 and 3. Mark the mesh currents as I1, I2 and I3. Mark voltage drops across various resistors. According to Ohm's law, voltage drop across 5 ohms resistance V5 is equal to I1 into 5. VA is equal to I1 minus I2 into 2. V1 is equal to I2 into 1. VB is equal to I2 minus I3 into 2. V3 is equal to I3 into 3. And finally V4 is equal to I3 into 4. So according to Ohm's law, voltage drop across a resistance is directly proportional to current flow through that resistance. So V is equal to I into R. Apply KVL for loop 1. In loop 1 there are 3 voltage terms: 10 volt voltage source, voltage drop across 5 ohms resistance and voltage drop across 2 ohms resistance. Voltage drop across 5 ohms resistance is denoted as V5 and it is given as I1 into 5, where I1 is the current flow through 5 ohms resistance. Voltage drop across 2 ohms resistance is denoted as VA and it is given as I1 minus I2 into 2. So applying KVL for the loop, considering first voltage term 10 voltage source in the clockwise direction, as we are moving from negative potential to positive potential, 10 volt should be taken as positive. Voltage drop across 5 ohms resistance and voltage drop across 2 ohms resistance must be taken as negative, as we are moving from positive potential to negative potential in the clockwise direction. So we can write plus 10 minus V5 minus VA is equal to 0. 10 minus of inside bracket V5 plus VA is equal to 0. 10 minus 5I1 plus 2I1 minus 2I2 is equal to 0. 7I1 minus 2I2 is equal to 10. Equation number 1. There are 3 voltage terms in loop 2. The 3 voltage terms are voltage drop across 2 ohms resistance VA, voltage drop across 1 ohms resistance V1 and voltage drop across 2 ohms resistance which is denoted as VB. According to Ohm's law, VA is equal to I1 minus I2 into 2. V1 is equal to I2 into 1 and VB is equal to I2 minus I3 into 2. Applying KVL in loop 2. Let us consider VA first. In the clockwise direction, as we move from negative potential to positive potential, VA should be taken as positive, so plus VA. When we consider V1, as we move from positive potential to negative potential, V1 should be taken as negative. Similarly, when we consider VB, as we move from positive potential to negative potential, VB also should be taken as negative. So plus VA minus V1 minus VB is equal to 0. VA is equal to V1 plus VB. VA is equal to 2 into I1 minus I2. V1 is equal to I2 and VB is equal to 2 into I2 minus I3. Applying KVL in the second loop and rearranging the terms, we will get 2I1 minus 2I2 minus I2 minus 2I2 plus 2I3 is equal to 0. So rearranging the terms, we can write 2I1 minus 5I2 plus 2I3 is equal to 0, equation number 2. In the third loop, there are three voltage terms. Voltage drop across 2 ohms resistance, which is denoted as VB, which is equal to 2 into I2 minus I3. Voltage drop across 3 ohms resistance, which is denoted as V3, which is equal to I3 into 3, and voltage drop across 4 ohms resistance V4, which is equal to 4 into I3. Applying KVL in the loop. Let us start with voltage drop across 3 ohms. Moving in the clockwise direction, as we move from positive potential to negative potential, minus V3. The next term which comes in the loop is V4. Moving in the clockwise direction, as we move from positive potential to negative potential, V4 should be taken as negative, minus V4. Next term in the loop is VB. In the clockwise direction, as we move from negative potential to positive potential, VB should be taken as positive. So applying KVL, we will get minus V3 minus V4 plus VB is equal to 0. So VB minus V3 minus V4 is equal to 0. V3 is equal to 3I3, V4 is equal to 4I3, and VB is equal to 2I2 minus 2I3. Therefore, according to KVL, we will get 2I2 minus 2I3 minus 3I3 minus 4I3 is equal to 0. Rearranging the terms, we will get 0I1 plus 2I2 minus 9I3 is equal to 0. Equation number 3. So we have three equations. 7I1 minus 2I2 plus 0I3 is equal to 10, equation number 1. 2I1 minus 5I2 plus 2I3 is equal to 0, equation number 2. 0I1 plus 2I2 minus 9I3 is equal to 0, equation number 3. So in matrix form, this can be written as matrix of 7 minus 2 0, 2 minus 5 2, 0 2 minus 9 into matrix of I1 I2 I3 is equal to matrix of 10 0 0. According to Cramer's rule, I1 is equal to delta 1 by delta, I2 is equal to delta 2 by delta, and I3 is equal to delta 3 by delta, where delta is equal to determinant of 7 minus 2 0, 2 minus 5 2, 0 2 minus 9. Delta 1 is equal to determinant of 10 minus 2 0, 0 minus 5 2, 0 2 minus 9. Delta 2 is equal to determinant of 7 10 0, 2 0 2, 0 0 minus 9, and delta 3 is equal to determinant of 7 minus 2 10, 2 minus 5 0, 020. So we will get delta is equal to 251, delta 1 is equal to 410, delta 2 is equal to 180, and delta 3 is equal to 40. So we will get I1 is equal to 1.633 ampere, I2 is equal to 717.13 milliampere, and I3 is equal to 159.36 milliampere. So we are asked to find Iy, which is equal to I3. So Iy is equal to 159.36 milliampere. Power supplied by 10 volt source is P is equal to V into I. So P10 is equal to 10 into I1. I1 is equal to 1.63. Therefore, power supplied by 10 volt source is equal to 16.3 watts. Thanks for watching Circuits Analytica. Enjoy learning.